All right. Unit 4, Lesson 3, second semester, 7th grade math. Vocabulary review. What does it mean to say that the fraction 5/9 is written in simplest form? Yes?
They can't be simplified anymore. They don't have a common.
No, you're nailing it. You're almost there. Go ahead. Do you want some help?
I think it's on the
You're about to use the right vocabulary word. You're really close. Does somebody know what she's about to say? Jose? Nope. Bokar? Nope.
Common factor.
Right. So you know that a fraction is in simplest form when there is no common factor for the numerator, which is the top number of the fraction, and denominator. Okay? Now, for number 2, who can walk me through number 2? Number 2. Leah.
I divided it by 2.
Okay, so you divided the numerator and the denominator by 2, but I want you guys to think about this another way because I'm trying to get you guys ready for what you're going to see when you get into some more algebra-related topics. So you said there's a common factor of 2, so we can write these numbers as the product of factors. And so if one of my factors is 2 for the numerator, what would the other factor be? 2 times what gives me 6? Right. And then for the denominator, you already said that one of your factors is 2. What would the other factor be? 4. So it makes sense that the numerator 6 is the same as 2 times 3, right? It makes sense that the denominator 8 is 2 times 4, right? Okay, so we know that if we have something in common in the numerator and the denominator, we can cancel those out, right? So this goes back to what you're saying you're dividing out to, but I want you to kind of think about it this way also, is my 2's are going away. They're common between the numerator and the denominator. I can make them go away. They cancel out. And so what were you left with? 3/4. Okay, any questions about that? All right. Number 4. Who can give me actually, we'll go to number 3. Who can give me number 3? Somebody I haven't heard from yet. Nicole. What's the common factor between 8 and negative 12? I can do better than that. 2 is a common factor. 4 is a better factor, right? So 4 is the greatest common factor. Okay, 2 is a common factor. We want the greatest common factor. So in this case, I can rewrite 8 as the product of 2 factors, 4 and what? What times 4 gives me 8? 2. Okay, and then in the denominator, yep.
That spider might follow me.
It's all right. That's just Spooky. He's my pet. Okay, so negative 12. Spooky.
Oh, I was thinking Terry.
Say hello to Spooky. Okay. Quiet, please. Hello. Thanks for the heads up, by the way. So 12, excuse me, 12 is a negative 12. So there's a factor I could pull out of here, negative 1, right? And you already said 4. And then what's the missing factor for the denominator, Nicole? What's the missing factor here? I need the product of these factors should give me negative 12. There's a factor I'm missing. 3, very good. Now we can cancel some things out, right? What do we have in common? You already told me it was the 4's, right? So in the numerator, I have what? 2 is left. And the denominator, I still have a negative 1 and a positive 3. What's negative 1 times 3? They're different signs. Remember what happens? it's going to be negative 3. So my answer is 2 over a negative 3, but if you're dividing different signs, so if you take 2 and divide it by a negative 3, what would the resulting sign be? Different signs. It's going to be negative. Same sign's positive, different signs negative. So it's negative 2/3. Got it? Okay. Question? Rayhan?
Why'd you put -1 there? Can you just put -3 times 4? And that would be equal to -12.
You could, but I want you to see something for the sake of the lesson. So you'll see what I'm talking about in a little bit. Okay? So that's a good question, and you're going to see why here in a little bit. Yep.
So if this positive 2 negative 3, the whole side's going to be
The whole thing's negative, right? Because they're different signs. And we're gonna see this in more detail in this lesson, so just bear with me. How about this one over here? Negative 15/3. I need to simplify that. Who can help me out with that one? Somebody I haven't heard from yet would be nice. Athila, yes, thanks for volunteering.
2, 3, 5, 4.
greatest common factor will be 4.
What? 15 and 3? Oh, we're doing 4, my bad, you're right. The greatest common factor is 4, yep. So in the numerator, I can say -1 times 4, right? In the denominator, I have a 12, and that's a -1. And you said the 4 is a common factor. What's left over?
3.
A 3, a positive 3, right? So -1 times a positive 4 times a positive 3 gives me a -12. A -1 times a positive 4 gives me -4. And then we can cancel a few things out, right?
Yeah.
Where'd Spooky go?
He's over there.
Over there.
Okay.
Like above the TV.
All right. He's just going back to his home. Leave him
Going on
alone.
an adventure.
So what cancels out over here?
Go find
-1s go away. What else? -4s. And now you see why when you divide by the same signs what's happening, right? What am I left with? What's my result? I'm left with a positive 1/3. Right? Because those negatives went away. They cancel each other out. Right? So now you see why if you have the same signs, they go away. At least in division. Okay? Any questions? Yep.
So if there's nothing left up top, we just
Put a 1. That's another good question. I forgot to mention that. If you've canceled everything off the numerator or the denominator, put a 1 there. Yep.
why did you put the negative?
Because that wasn't the factor we were canceling out. So I needed to account for that being a factor, -1. Like over here in number 3, I still had a -1 left over. So I ended up with a -3 in the denominator when I multiplied these factors that were left over. Okay? But here, they were gone, and that's why I ended up with a positive number. Both of them canceled out. Here, they didn't. I still had 1 left over, right? So now you start to see why we end up with a positive or a negative in different situations. Okay? So over here, take a look at this. What's the common factors between -15 and 3? McKinley, go ahead, walk us through this. Right, -1. And then you said the common factor was 3, right? And then there's another factor I need to balance this out so the numerators are equal, right? What's missing up here? 5, right? So 5 times 3 times -1 gives me -15. And in the denominator, I just have 3. That's all I got there. So then what cancels out? The 3's are gone. And then I like the question you asked earlier. So what's in the denominator now because everything canceled out? A 1. And then what's in the numerator, McKinley? -5. Good catch. Now we know anything over 1 is just what? Itself, right? So my answer is going to be -5. Now, you're going to see why I wanted you guys to think about it this way because of what we're doing today for the lesson. So let's take a look at what we're covering today. I'm going to go ahead and read this since we're putting this in the class channel. What you'll learn: to find the slope of a line and to use it to solve problems. The new vocabulary: slope, rise, and run. Okay, why learn this? Elephants will not climb a ramp with more than a 33-degree slope. When ramps are constructed, they must meet safety standards that ensure they are not too steep. You can understand what factors affect steepness when you understand slope. So here's our new vocabulary word, slope. Let's see what it's about, and here's an example. Slope is the ratio that describes the steepness of a line. Slope compares the vertical change, the up and down change in a line, called the rise. So rise is up and down. The horizontal change is called the run, sideways. For any 2 points on a line, the ratio of rise to run is the same. So if we have a line and we have two solutions, remember what a solution is? A solution is a coordinate where the x, if I substitute into the equation, will give me back that y. Does that make sense? Do you guys remember from yesterday, if it wasn't a solution, it's not going to sit on the line. Do you guys understand? Okay, so points that are on the line, they're collinear. If it's not a solution, it's not a point on the line. You can't use it to calculate slope for that line. So here we have a line drawn in the coordinate plane. And let's take a look at this. So we have the, what do we call this point right here, 0, 0? We have the origin. They give us that point. And we have another point. And this coordinate is 3, 2. So the x coordinate is 3, and the y value is, the y coordinate is 2. So there's actually two ways to calculate the slope from any 2 points. And so I'm just going to show you one for now. But both methods will give you the same slope. Both approaches give you the same slope. All right, so if I start at the origin, I need to first figure out what's my change sideways. What's the horizontal change? We call it the run. How many units do I need to go to the right to line up with the other coordinate? 3. And if it's going to the right, what direction is that? Positive or negative? So 1, 2, 3, that's where I end up at, and I get a positive 3 because I'm going in the positive direction. Now, in order to get to the right level of the other coordinate, I have to go which direction? I have to go up, I have to rise, and going up is associated with what sign? Positive. So I'm going in the positive direction up. And how many levels do I go up to get there? 1, 2. So it's a positive 2 over a positive 3. Do you guys understand? So slope is going to equal 2/3. Okay? Now, in the last unit, do you guys remember you had a t-chart? And then you figured out the common difference, and that's what you put in front of the x, right? Okay. Well, you're not always going to get a whole number common difference or a whole number that goes in front of the x. Now we're trying to see what happens if, how do we figure out any coefficient that goes in front of the x. So this function really quickly is going to equal 2/3 x. And because this goes through the origin 0, I can put plus 0, but we don't usually see the equation written that way. Usually we just see the equation written without the plus 0. Okay? But just know that the plus 0 is not, it's not incorrect, but this is typically how you'll see that function. And so we can substitute these values and see that they work. So if I have my t-chart and my y, I can test that for 0. If I substitute 0 in here, isn't the answer for y going to equal 0? So it works. Let's try the other point for 3. If I substitute 3 in there, does that work? So I have f at 3 equals, we're going to multiply by 2/3. And what is that going to give me back? What's 3 times 2/3? 6/3. What's 6/3 equal? 2. Isn't that my coordinate over here, 3, 2? Okay, so I didn't have to make an adjustment because it went through the origin. Okay, remember in the previous unit, sometimes we had to make an adjustment, sometimes we didn't. We don't need to make an adjustment when it goes to the origin, and we're going to see why on the next examples. But before we see why, let's take a look at this next example, finding slope. So there's 2 ways to find the slope. I'm going to show you the first way, and then I'm going to show you another way. And then this goes back to what you guys asked earlier about the signs with the numerators and the denominators, and you'll see why I brought that up the way I did. So for here, if I'm going to start at this point, okay, and I want to end at this other point, we got to pick a start and an end point, okay? So we're going to start here. All right, so this is one approach. Now, to go from the point 3, -1, to the point -3, +3, first let's figure out what my run is going to be. Well, my run, we see we're going to the left, correct? And we're going to the left, so if we're going to the left, what sign do we associate with going to the left when we're talking about horizontal axis? Negative. So do you see why it's a -6? Okay, we good? Now, if we shift 6 units to the left, we still have to align ourselves up and down to get to the point -3, 3. Which way are we going to go from here? Up. And what sign do we associate with going up? Positive. So it's a positive. How many levels are we going up? 4. So that's a +4 in the numerator. Now, they're different signs. The numerator is positive, the denominator is negative, right? So when you have different signs, the resulting sign is what? Negative. So we have a negative, and then 4, 6 simplifies to 2/3. Okay, so that's my first example. That's one way to find the slope. Let me show you the other way. So here we started at 3, -1, and our slope we calculated was -2/3. Now I can start another way. I can start at the other point. So let's start here. And let's see what happens now. Let's go ahead and do my run. So to line up horizontally, which direction do I need to go? To the right. And I'm going to go how many units to the right? 6 units to the right. And when we go to the right, is that a positive or a negative? Positive. So my run is +6. Now, I got to align myself on the right level. So which direction am I going to go now? I'm going to go down. And if I'm going down, what sign do we associate with going down? Negative. And so it's a negative rise. And how many units? 4. -4. So I have -4 over a +6. But if I simplify that fraction, what's the fraction going to be? -2/3 still. So do you guys understand the two approaches to get slope? And do you see why they're equal? Okay, question.
So on a quiz or a test, how would we tell this?
You can pick. I'm just giving you that it both gets you the same place. Okay? And actually, sometimes you have more than one point. It doesn't matter which 2 points you choose. Does that make sense? As long as there are points on the same line. Okay, so here they're trying to just give you 2 points so there's no confusion. But now what I'd like to do is I'd like to write the function out. Can I write the function out for this? The equation for this line. Here's the equation for the line. The function of x equals, what goes in front of x? Negative what? 2/3. All right. Now, I'm not so sure that that's going to work just yet, but how do we test it out? How about we try one of these points that they gave us? Can we try, let's try +3, -1. If I put +3 in here, what do I get back? So let's try +3 and see if we get back -1. So f of 3 equals -2/3 times +3. What's that going to give me if I simplify that? Two-thirds times 3, what do I get? 6/3. In this case, it's a -6/3. And -6/3 is really what? -6/3 is really what? It's 2, negative 2, right? But what do I want to get back? I want to get back what? I want to get back what? Negative 1, right? So, but you're telling me this is negative 2. So how do I fix this so I end up with negative? No, it's a negative 2. I want it to be negative 1. Plus 1. So if I plus 1, we'll see that what we get back is negative 1. Okay, so I just want to make a connection here. Look at where my graph intersects the y-axis. It's called the y-intercept because that's where the line crosses the y-axis. Where does it cross the y-axis? What coordinate is that? 0, 1. That's not a coincidence with that equation. So if you look, 0, 1, this is called the y-intercept. Okay? So, slope is the number that goes in front of the x. The adjustment that we've been talking about in the past, that's where my line crosses y. Do you guys understand? Okay. So if I had my equation without the plus 1, it would be parallel to this line, but it would go through the origin. So moving forward, I'm trying to make some connections here. I need you guys to go ahead and calculate slope. So I'm trying to get you guys ready for some things coming down the line, later in the unit, while I'm trying to show you like the connection with slope and what we covered last unit. Okay, so if you guys can go ahead and calculate the slope. (102). That's just spooky.
No, that's spooky.
Okay, come on, calculate rise and run and the slope. Remember, there's 2 ways to think about this. Now, Teray had a good question. Are you finding the function also? If you want to show me that you can piece things together with kind of like the breadcrumbs I've given you, you could find your way home. I gave you the pieces. If you can find the function, then you're going to be well ahead and you're going to have that skill down. So to see if you can do it, that'd be great. That's not the point of the lesson. But if you could find the slope and you have time, see if you can come up with the equation too. Mm-hmm.
Can I use the bathroom after Dominique?
Okay, who can tell me what the run is going to be? So here, in this problem, it looks to me like they started, that's where they started. Okay, what was the run? Class, what's the run? positive 6, we're going to the right, so plus 6 to the right. And what's the rise going to be? Very good, positive 3. And then if we simplify positive 3 over positive 6, what's that going to be? It's going to be a half, a positive half. Okay? So let's go and take a look at the alternate method. If I started, instead of negative 4, negative 1, if I started at the point 2, 2, my run would be what? Which way would I be going to get to the other point? No, run is sideways. I would go left. And Bokhar, how many units to the left would I be going? Minus 6. So here my run is negative 6. Okay? And now what about my rise? My rise is, which way am I going? Down. And what's the sign going to be? Negative. And so now, hopefully you see why I went over what I did in the warm-up. So now it's a negative 3. Okay? And so now I have a negative 3 over a negative 6, right? And we know that's going to simplify to what? It's going to simplify to a positive half. Okay? So now you see, I know you guys look at the warm-up like, why is he doing it this way? But now you understand, right? Okay, so let's go back to the equation. Some of you might have tried to write the equation. And if you did, let me show you what the equation would be. It's f of x equals the slope, a half, times x, and then plus the y-intercept. Where does it cross the y-axis? Plus 1. Because this is where it crosses the y-axis. This is the y-intercept, right? So the y-intercept is 0, 1 is the y-intercept. Okay? And this is also the y-intercept. Okay, do you guys understand? So I'm trying to give you like a cookbook method on coming up with these rules or these equations of a line. Okay? So now maybe you guys are starting to connect with what I tried to teach you in the last unit, because I was trying, it seems like a lot, and it usually is for 7th graders, so I'm trying to make it seem like you're digesting smaller bites by showing you stuff ahead. All right, I'm going to skip this one. I want to go over this example. Now, here they want you to draw a line that goes to the origin and has a slope of negative 3/2. And just to clarify, because some students got confused by this earlier, negative 3/2. Okay, so first of all, the origin. What is the origin? 0, 0. So they said, hey, we got a line, and this line goes through 0, 0, the origin. And what you need to do is you need to draw a line that has a slope of negative 3/2 and goes through 0, 0. Okay? So first we need to write two fractions that are equal to negative 3/2. Think about the two methods I showed you to draw the same point. Okay? So what are two fractions that are equal to negative 3/2? So let's go ahead and do that. What would my run be? What would be one way to write my run from that slope? What's one way to write my run? No, from that slope. The slope is negative 3/2, right? Remember the numerator is what? The rise. The denominator is the run. So what can I use for my run? 2. So if I use a positive 2, what does my numerator have to be? Negative 3. Because a negative 3 divided by a positive 2 gives me a negative fraction, right?
Excuse me, may I have Nicole start for early dismissal, please?
Yes. So if this is my fraction here, there's another way I could write this. What's the other way I can write this? Instead of using negative 3 in my numerator, what can I use?
Y'all heard that?
Yes. I can say positive 3, but what would my numerator have to be? Negative 2. Now, just like we had two methods to calculate slope, or two approaches, we have two different ways to find another point so we can draw our line. Got it? So which ratio do you want to use? Okay, let's use the first one. Now, I can't switch back and forth. I use the first one, I have to stick with the first one. I got to use that rise and that run. I can't go to the other one. Got it? So from here, your run is what? What's my run from the first one? It's positive 2. So which way am I going to go? To the right, 2 units. That's plus 2. And then what's my rise say? It says drop, because it's negative. How many units? 3. Minus 3. So now we have this other point right here. And this other point is what? 2, comma, negative 3. Now this is easy because this is going through the origin, but they're not always going to give you a point that goes through the origin. But now let's figure out, using the other slope, find another point. What's another point? Let's go ahead and find the run. What's the run from the origin? Which way am I going to go? Left, and I'm going to go 2 units to the left. So I'm going minus 2. And then my rise, up 3. 1, 2, and 3. That's plus 3. Okay, now if I was to draw a line through all of these points, but what is this point right here? Let's name this point really quickly. Negative 2, positive 3. That's that coordinate. If you notice, do you see why it doesn't matter which one I use? Because watch. The line's going to go through those points. It's going to be the same line. Do you understand? Okay. So, I could have said minus 3, positive 2. And then the alternate method down here, we just did that, positive 3 and negative 2. And let's go over the equation really quickly, because this one's, it's going through the origin, right? So this one's easy. What's the function going to be? What's going to be my negative 3 halves x? And because it goes through 0, I don't have to make an adjustment. I could put plus 0, but it doesn't matter. Okay? Goes to the origin, so I don't need the plus 0. I could just leave it out. Okay. Are we good? We're getting a better understanding of slope. Now this one threw some students off because it wasn't going through the origin this time. This time, the point we're starting out with is point P, which is 2, 1. So I'll go ahead and graph 2 and 1. There's point P. And now what I need you to figure out is another point so we can draw our line. There's 2 ways to do this. And if it'll help you, that's the slope, 4/3. There's 2 ways to write that, right? Can somebody give me one way to write the slope so we can find a point? What's one way I could write 4/3, positive 4/3? What would my rise be? Positive 4. Well, if I chose positive 4 for my rise, what's my run have to be? Positive 3. So positive, positive, and positive give me a positive fraction for my slope, right? So we're going to use the rise and the run you just chose. So my run is which direction? Right, because positive direction is right. And we're going to go 3 units, so plus 3. And what's my rise? Am I going up or down? Up. How many units? 4 units up, plus 4. And so where does that place me? What's this new point that I have that's going to be on my line, collinear? It's going to be, nope, from the origin over here. What is it? 5 and 5. So the origin, this is just a dot. This is a dot on the line. We have to name our coordinates from the origin. Don't count from the dot. Got it? That was just a point, arbitrary point. We always name our coordinates from the origin, count from the origin. Okay, so that is one point, right? But if we wanted to, what else could we have used instead of positive 4, positive 3? I could have used, and I'll just write it down here. -4, and -3, right? And we see -4 and -3. What happens when we divide two negatives? It's still a positive. And I had another grid over here, but I'm just going to reuse this one so we can illustrate the point off the same graph. So here, if I go to the left, 3, that's a -3, right? -3. And then I would have to go -4, so I'm going to drop 4, -4. What's the new coordinate we have here that's going to be collinear with point P? Here's my origin right here. -1 and -3, because we drop here -3. -1 and then drop 3. And then we see that all of this is in the same line. Okay, are we good? All right, the vertical change between 2 points in a line is called what? Vertical change. What do we call that? The rise. Very good. The horizontal change is called the what? The run. Nice. Use the graph below to answer the following questions. Is the slope of the line positive or negative? Nice. As x increases, my y's decrease. Okay, that's a negative slope. So the answer is negative. Now, just to illustrate something, it's important that you guys do this exercise really quickly. We're going to use points A and D to find the slope of this line. So you guys identify what A and D are. You calculate the slope from those 2 points. A and D only. Got it? This is important. For you guys to leave out of here, I need you to do this so you have an understanding of something. I mentioned it briefly earlier. Somebody had a question about it. I want you guys to connect something without me telling you. Does anybody need the help with the formula for slope? What's on the numerator? The rise. The denominator is what? Run. Okay, can somebody tell me the run from A to D? What is the run? Sophia, what's the run? So I'm going from A, run is sideways, right? So from A to D, how many units am I going in which direction?
4.
So A is here.
3.
So it's 3 to the right. So what is the sign? Positive 3. Okay. So positive 3. And then my rise, I got to get to the same level as point D. So what am I doing? I'm dropping. And how many units am I dropping? 6. And when we're going that direction, what's the sign going to be? So -6. So I have -6 over positive 3. What is that going to simplify to? It's just going to be -2. If you got -2 over 1, make it a whole number, -2. Now what I need you to do really quickly, I need you to do the same thing, but now you're going to use B and C. This one's even easier. Use B and C. So can somebody tell me what the run is to go from B to C? Who can tell me what is it? Miriam, what's the run? It's going to be 1 plus 1, right? That's my run, plus 1. And what's the rise going to be? -2. We're dropping 2, so -2. Can you simplify that fraction? -2. Is there a difference? So the whole point of that exercise is this. As long as you use 2 points, it doesn't matter what 2 points, if you simplify the ratio, you'll get the same slope.